here is exercise 13. Chromium compounds exhibit a variety of bright colors.
Again, I don't care.
When solid ammonium dichromate, oh, now we're getting some information, right? Solid ammonium dichromate.
Holy cow, I don't know what that... Oh, it tells me. It tells me exactly what it is right here.
So here's the substance.
Okay. Whew.
When solid ammonium dichromate, a vivid orange compound, is ignited, a spectacular reaction occurs.
I don't care.
Although the reaction is actually somewhat more complex, let's assume that here the products are solid chromium, chromium 3 oxide, nitrogen gas, right, which is N2 because nitrogen,
right? So it's diatomic N2,
and water vapor. Okay, so water gas. Balance the equation for this reaction. So this is a substance that we're starting with. So let's write that down. And H4, there are 2 of those. Got my dichromate, which you guys might not have memorized, but it's always a
Cr2O7.
And that is a solid. So what are we producing here? Chromium 3. That means that this chromium has a +3 charge. So this has a +3 charge, and there's an oxide. And we know that
Oxides always have a -2 charge.
So I know that CrO is not the correct equation
because these charges are not balanced. But it's a 3 and a 2, so I have my 3-2 trick,
right? Which is I cross these down
as my subscripts.
And now I am good. Now it's a solid.
I'm going to get in my
phase right there. And what else do I have? I have nitrogen gas. The gas, so I'm going to write G. And what else am I making? Water vapor.
Vapor is another word for gas. As the added information of being a gas, but normally that substance at room temperature is a liquid. So yes, you guys know that room temperature water is typically a liquid, but in this case, after this reaction, there's enough energy present that it's become a gas, right? So saying that water vapor, it's telling you that it's a gas. Now, we are not balanced here. That's actually what we're asked to do. So start with the most complex thing, which would be this right here. And then if you get stuck, double something. Now, the other rule that we want you to remember, the other suggestion we want you to remember is if there's any elemental substance, which there is right here, just pure nitrogen, balance that one last, right? So let's remember this stuff. So we're going to start with the most complicated thing. We're going to leave the element for last. And if I get stuck somehow, try doubling all of the coefficients. Right, so those are 3 things we want to remember. So let's count the nitrogens. I have 2 nitrogens here, 2 nitrogens here. So that kind of already seems like that's balanced. Let's move on to hydrogen. There are 8 hydrogens on this side. There are only 2 on this side. So in order to make that balance, I'm going to have to put a 4 in front of the water. So now I have 8 hydrogens here, 8 hydrogens here. Next up, 2 chromiums. That's all good. Let's look at the oxygens. I need to have 7 oxygens. I have 3 oxygens from the chromium 3 oxide, but I want 7. But I'm not done yet. I have 3 from here. I also have the 4 from the water, so I do have 7. And so I'm done. All I had to do here was throw in that 4, and I was done balancing. Now, before we end this exercise, you might be wondering, how do I know when I'm supposed to include the states of phase and when it doesn't matter? The rule of thumb, guys, is if they give you the information in the problem, in the question, which they do here, right? Solid, gas, vapor. If they give you that info in the question, include it in your answer.
Right? So solid, solid, gas, gas.
Just so you know, this actually is a pretty spectacular reaction. So if you want to see an example of one, you can check out this YouTube video, and that might be fun for you. It might not. Whatever.